Good morning, my friends. Roger once again, Mud Fossil, a university making the biggest claim in history about the smallest particle ever seen, which is that. How can I say that? Well, here's how I can say it. These both were particles of light that separated in a venturi into electrons, and those electrons spinning through space create these polarized fields called Higgs. This one spun backwards. Instead of spinning the bar magnet in a right-hand spin, it spun backwards, and that appears to gather the power within itself, and then it collided with a standard Higgs and created this, and appears to be stepping down to a similar appearance. Now, how did we get this? How did we get these? And why do I think that's the smallest particle ever seen? Well, it's smaller than that. And let's see how we got that. Okay, this is how we got that white particle. It is spinning backwards. These are all spinning to the right. That's spinning backwards. Now, this is the venturi coming towards us. And these little white spits are the bosons going so fast they have not had time to smash into the atmosphere. As they slow down, poof, they puff up and they start to make that spin, which does all these little polar particles surrounding the spinning bar magnet. Basically, that's what's going on. Then that concussed with one of these. Now, let's see how we got to this point of Cherenkov in plasma. Okay, so where are we in the chain of events? I said that's the Cherenkov, this is the bosons, these are the Higgs fields. Now, this is where we are, the Higgs fields. These are the bosons, and they came out of plasma, which was created by the crushing laser into its own regions, which they control huge regions around every one of these particles. And when they get forced into each other's regions, they turn into plasma, and they just get crazy. And when it came out of here, they didn't come out as light again. They came out as electrons. And I'll show you that. All right, this is the red construction laser. It's a GLM-15 Bosch. And it's a pulsed red laser. Now, it doesn't make that huge pulse of red laser. The laser light is literally a dot like that right in the center, and I'm going to prove that to you. I'll show that to you. And it's a dot going swish. Now, why is all this looking this way? It's exactly like a jet fighter going through the atmosphere. It creates a wake, just like a boat going through the water. It creates a wake. The boat is here, the jet is here, the wake is here. All right, now, I just told you that's a particle. You see that little tiny spot there? That is the particle that I was just talking about. All right? That whole wave is not a whole wave. This is just the particle. And because the particle has so much influence around itself, it comes through the air, and everybody's got to get out of the way. That's why when it first came through, all those little particles were concussed. Now they're being concussed backwards because of this explosive activity here. Those are coming back and causing these particles that are in the air, which are nothing more than this particle, just exactly like that particle, only they exist only in the air, just laying around in the air doing nothing. Well, when this guy comes through, he concussed them all going this way, and now I'll show you that in a second, but you can see these waves of concussion are reverse EMF. It's called electromotive force, in reverse, because of the explosive nature of these impacts. The backwards push. That is reverse EMF. These particles are being concussed into glow, which is luminescence. They are being concussed into a very small amount of luminescence. These are much more luminescent, and these are less and less as they come back. But let me show you the wave just coming through the air. Now, remember this, and you can look it up. There's something called a 21 centimeter line. I believe that's what it's called, 21 centimeter line. And it means that, I believe it's hydrogen controls 21 centimeters around itself. That's like 8 inches, I think, something like that. I forget exactly what the inch size is, but it's huge. So as that goes through the air, all of these are perturbed. They are concussed. And when you concuss any particle, I don't care if it's friction, slap something, ignite something, push electrons into something, they go into glowiness. They are luminescent corpuscles. And guess who said that? My good friend Plato. All right, now you just saw the reverse EMF. This is the forward EMF, and these are all being concussed out here. Here they're being extremely concussed, glowing. Here they're not so extreme, but they still, everybody has to move out of the way. Once you just push even the tiniest bit, you're going to feel friction, you're going to feel heat. That's glow. That is literally atomic glow. Friction and heat is atomic glow. Okay, we're seeing this as like a two-dimensional thing, but that's really a three-dimensional ball. That's a three-dimensional ball going through the air. Now, we're seeing it, and you could see some of the structure going down into it. But anyway, the ball is being stretched and pulled, and all of the particles that are in it are starting to glow because they are now accelerating past their ability to just exist within this atmosphere. They're going too fast, and now they're glowing, and the particle nature of light is evident very clearly. Very, very, very clearly. Acceleration is undeniable. I don't know how anybody could deny that. And the particle is also undeniable, and the concussion and the glowing of the particles that exist in the air, which are primarily water molecules. Water molecules are everywhere. There's a certain amount of humidity in the air. It's just the way it is. And the drier the air is, the less humidity. But every water molecule is a highly polar molecule, first of all, and they glow when they get concussed. Now, so we have the light, which is a ball, which is huge, but the particle in the center of it is that. The ball is being stretched just like you pull a basketball or a beach ball or something so fast that the front of it goes, and you end up with like a cone going back of the ball, which is all of this stuff right here. This is exactly what's going on. Now it's being concussing against itself because itself is bouncing back. And then it starts to glow heavily, and it turns into a plasma here. Now, this is the really interesting, well, I mean, the whole thing's interesting. But this is very, very interesting here, because at this point, I was really perplexed. Because how could, I'm going to show you the particle in a second, and it has a black and a white to it. And the black and the white ends up showing up out here, and I'll explain that in a minute. But here, there's nothing. It's 100% solid, absolute Cherenkov radiation white. Absolutely plasma chaos. 100% chaos. Plasma. No structure. All of the bits are just in chaos, smashing into each other in every possible way, glowing as much as they possibly can glow in this restricted space. Now, coming out of this restricted space, they are all negative now. Now they are all negative particles. There is no, well, when I say all negative particles, they're all electrons. And they all want to be away from each other as much as they can. Originally, they were bar magnets. Now they're all going in disarray, and they're shooting out from each other, and that's what sets up these stripes. These are, I believe, repulsion stripes. However, at a certain point, certain black spots start to take on, and that's because the particle is spinning through this space. It's not a wave going like this, up and down, up and down. It's a spinning particle going this way through that orifice. So some of it comes a little this way, some of it comes under the bottom, goes that way, comes over the top, most of it goes through the center. But that's what sets up these interference patterns. That's my take. This is my impression of these particles. They're spinning, right-hand spin, like this. Spin, 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 spin. When they hit down here, some go this way, some go straight through the center, some come under and go out this way, some come back over this way. Now, and I can show this pattern. Rod Warren did all of these pictures, and I did some experiments myself, but he's just outstanding with it. And and he discovered that Venturi just by accident, and I discovered the fact of what it was doing, because I do the atomic theory. So let's go on a little further. All right, this appears to be one of those disks spinning, and that is the central particle of this thing doing it, and it's perturbing things that are in a circular manner around it. So in other words, this particle here would be in the center, right here, just like this. All right, it would be in the center of this frame of particles, let's put it that way, because you saw those disks. There's a whole series of disks around and around and around, and that's these disks, but this particle powers the disks, and they follow it around. You can see it's expanded here and it's compressed up here. That means it's slowing down. This is one of the more interesting shots. That's the Venturi. Everything's coming directly at us. Now these are the little bosons, zip, 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 and then they're fluffing out into the Higgs fields when they slow down enough to polarize the particles that they are spinning through. Now, that's the one we're going to talk about. That one is a reverse spinner, I believe. And the reason I say that is you see it has no field surrounding it, none whatsoever. It is pulling power into itself. The other fields are being spun this way, throwing out and polarizing the particles surrounding the particle. This one is spinning backwards and gathering the power into itself. That's the only way I can take that. If you could figure out a different, they came through the Venturi as the same particles. They all came out of the red laser the same way. There's no reason that one should be different than the other ones. It is not exhibiting any sort of a field. None. It's taken its own field into itself. And then we will see it concuss with one of those fields, and then it gives off a light trumpet, it looks like to me. I don't know what you want to call it, but it's not a full field, but it might fluff into a full field. I don't have any other examples of it. All right, and this is that field. All right, this is that little tiny particle right there. Now, it has some structure to it, you can see. That structure is now starting to form one of these exact same disks. Well, I mean, I don't know if it's going to be exact same, but it looks to me like it's even going to be the same size. But what is this? Did this thing gather some extra power and it's spitting off? Or is this leaking out and being part of a light? But I'm telling you right now, this and this, these were light-driven fields. In other words, there's a particle in the center. They're spinning like crazy, forcing these fields to exhibit around it. This one has just the opposite and has no field whatsoever until it impacted with one. Now, there's a lot of things to think about here, and I don't have the answers to these things, but the current atomic model does not work. Electron flood works for every single thing. There's not a single thing. If you could present me with any single electronic phenomena, I think I can explain it with all of this plethora of bits. and how we see these bits rearrange, and how we see resonance stability, and I'll show you that right now. All right, stability is in noble gases. They have 8 electrons in their valence shells. Well, guess what? That's called the octet rule, and it's a chemical rule of thumb that reflects observation that elements tend to bond in such a way that each atom has 8 electrons in the valence shell. That is the outside shell. It says it gives it the same electronic configuration as noble gases, which are stable gases. So we're looking for stability at certain resonance frequencies and exactly what electron flood states. And here they are. All right, this is brush pulp, and it's a very good demonstration of what I believe is resonance frequencies. Now, this is salt on a vibrator, and it's going to create different frequencies, and that will stabilize these into a form and a pattern. And that form and pattern, I believe, is the mimic of atomic structure. Now, at the lowest frequency, it starts out with the s orbital. This is the s orbital. So that's your nucleus, and then the electron can exist here. You can have 1 or 2, and that's it. So you'd have 1 here and 1 here, or 1 here and 1 here, or just 1 anywhere. That's your lowest orbital. Now, that is a stability at 345 hertz. Now, when you go up to the next stability, you're outside of the s orbital, and you have your 8 rule of 8, the octet rule. And it follows right up the line, and very, very, very well, all the way up until you get to a certain level where 8 no longer works, and then everything starts to fall, well, not fall apart, but achieve a different look to it than we can actually see the 8s. Because you can see 8 here pretty well in almost every pattern. It's very, very obvious. Some patterns, so you have to look a little straight. See, but there's your S and there's your P orbital. So, and it just goes on, and some of them sort of entangle a little bit here and there. But if you worked it out, you're going to see that this is all what resonance frequency means. That the whole pile of them are trying to get together, and they're pushing and pulling evenly at a certain number of particles. If you're over them and this wave is missing its piece, it's going to fall apart. If you have too many pieces hanging around the edge, you lose your pattern. That's nuclear decay. All right, I just want to explain to you what is happening here. The other shots were like this, where they were right in midair. Where he was showing them, just boom, boom, he was taking pictures right in the midair, where the laser's just coming out, where it's expanding, where it's going through the Venturi, the plasma coming out, the bosons turning into the Higgs, all that was shown. Now, what did we see here? Little different. Instead of having it just display in the air, there's a backplate here. Right? And it's just like a white backplate. And as that stuff sprays on it, he's shooting the picture down this way and looking at the pattern that it creates, which is that circular pattern on the black backplate, instead of just looking at it as it comes off into the air. That's the only difference. Now, again, Rod Warren from Australia, he did the light pictures. All right, all the atomic theory and that sort of stuff is what I do. Now, let's just go through this one more time, because it's very, very basic and simple. The laser was a very simple little laser right here. Zip, 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 shooting out these pulses. They accelerated. They turned into plasma. And I want to make one statement right now. This is electrons. They own regions around them. So do protons, which they get these big particles, these big nucleuses, let's call them. They own big regions around them. When you force them into the same restrictions like this, I believe you could get plasma there. And if you could get plasma there without, this is a passive, this is just 2 nails. This is 2 construction nails. That's all it is. I mean, I'm serious. That's all it is. You get, I mean, this is just bizarre. But if you could get plasma with a couple of construction nails in a vacuum, and then what comes out, plasma from from dense particles, which are the heavy hydrogens. When you break them into little bits, there's a lot of extra stuff left over, and they end up with helium. The extra stuff is energy. That's fusion. So if you can get them to turn plasma here, and coming out of here, they should turn into their base molecules, which would become helium, instead of heavy hydrogens, which are unstable hydrogens. They want to find stability. And if they come out in plasma, the stability will be helium. That's the key, that's the theory. So if they turn into helium, what's left over is literally electrons. It's just a ton of extra power. And it's like 1/5, something like that. If you do it right, you should be able to take, these heavy hydrogens and turn them into heliums, and then get like 1/5, 20% of whatever you put in comes out in free power. I mean, well, you got to accelerate yeah, it's not free, but I mean, it's fusion. It's possible fusion. Anyway, let's get back to what's coming out of here. You got your laser, you got your pulse, bip, 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 bip. You got your acceleration, you got your plasma, you got your bosons coming out. You got your Higgs coming up as they start spinning out like that. All right. That's what the particles look like, as you saw, positive and negative sides. And that's what, when they break and smash apart, you end up with one of these. Now, you see these little tails? They're pulling against each other here. Now, I don't know whether they have any pull to them outside of being pulled against that, or these would be just free to just be that little bar magnet floating around and be affected by whatever it bangs into. And I believe that's what it is. I don't think, because this here are pulling each other together. You saw where they were pinching. I'll show you that one more time, and then I'll let it go. I think I showed the green electrons, but these are the red ones. Same thing. Positive, and you can see a little glow positive trying to suck that negative into it, or whatever they are, negative, positive, either way. And the same thing's happening up in here. Now, and then it starts to step down, and there's only two places where it exhibits this back-to-back dipole nature. And then, well, here. This is coming out of, I believe this is coming out of the accelerator. Again, Rod took these, and I'm pretty sure this is the case. I'm pretty sure it's coming this way. They're higher energy here. They're starting to step down here, and then they flatten out there, and they turn into like red light again. It appears. That's what happens. I'll show you what they end up doing. I believe is what they end up doing is turning right back into the red light. And then eventually they start to settle into their trails. I believe this is the central area. As they come out, they're coming out like this, but the central beam comes out with the main number of particles and the most glow. I think I mentioned before that these were different colors because this one was being crushed and so forth. Well, I'm starting to think that the light is not penetrating exactly the same. It's shooting more off to this side than this side, and we're getting more of impact over here. Let's just go with that. That's now the take on it. This is a work in progress. I don't have every answer, and sometimes I'll say something one day, and the next day I'll figure out, that doesn't really make a whole lot of sense. Just like this single particle theory, I've been going to, you have to have a positive and a negative. No, you got a positive and negative. Every bar magnet has a positive and a negative. When you glue them together, they're back to back. Exactly what we see.